Hi everyone, welcome. My name is Piyush Vijay. I'm a software engineer at Apple. I have with me my colleague Charlie Moulter. We work on an infrastructure team which provides Kafka as a service. We are very excited to be here and share some of our experiences. We'll talk about some of the challenges we face day to day, our solutions to them, operations, our security story in detail. What's the value in providing Kafka as a service? Who would use it and why? So Kafka is used across multiple groups for a lot of use cases. Some of them are mission and business critical. Kafka operations are not really trivial at scale. They are complex, require dedicated tooling and expertise. Kafka is used by different groups. There are multiple deployments. There is a varying level of expertise within the company. The knowledge is scattered, and often teams interact with each other. They use a single topic. So there's a lot of value in having a complete and cohesive access control story. So overall, it makes a lot of sense to provide Kafka as a service and facilitate easy and quick collaboration across the board. There are clear advantages of doing this. First one is developer productivity. For example, if you have a use case that you want to experiment with, it would be very nice if you don't have to go through the hassle of procuring the hardware, deploying the services. If there's a central platform which is easy and quick to use, you can just use it for your new use cases, POCs, and it can save a lot of developer time. There is added advantage of having the centralized expertise and support available to you always. Oftentimes, we have seen when some teams start using Kafka for some time, they have common set of questions. There's a lot of value in consolidating the knowledge and expertise that we have. We invest a lot in self-service tools to further reduce the time it takes for our customers to use our services. We have an API. There is a nice UI on top of it. Anyone can go to Kafka Service Portal and start creating topics, clients. They can give access to their topics that they own to other teams within the company. So overall, we make it very easy and quick for everyone to start using our services. Another advantage is improved reliability. We put in dedicated effort in operations, and we solve hard operational problems for everyone. We procure hardware, we manage clusters, we deploy services, we provide operational support, we do consulting, we provide security solutions which are standard across the board, and we also recommend client configurations, and as Charlie will talk about later, we have a way to even auto-inject some of the common client configurations. We make it very easy for everyone to integrate with other technologies in the Kafka ecosystem. For example, service discovery. We have defined SLOs on uptime and retention for our queue and production use cases on all our clusters. Overall, Kafka is integral to multiple systems at Apple, and there's a lot of value that comes with guaranteed reliability. Another advantage is have a security solution which is standard. As I touched upon earlier, there are like multiple teams who have deployments, and like if the security story is not cohesive and like standard, you often run into problems when trying to access data with like some other team. So we have invested in end-to-end data security and privacy framework, which is very interesting, and I'll talk about in the later part of the presentation. We have standard setup for authentication and authorization. And as some of you might know from experience, security is awesome, but there's often a trade-off that comes with using security and the ease of use and user experience. So overall, we invest a lot in security features, but we keep it very simple for people to use it and understand it. And we take an approach which just like works for everyone. Quite naturally, these things are challenging to do at scale. One of the main challenges to how do you ensure that the operational cost doesn't increase linearly as the number of use cases and teams using your services increase? For example, once you have hundreds of clusters, how do you ensure the configurations stay in sync? How do you do attended maintenance on the clusters once like you have a large number of clusters? Another important consideration for us is user experience. We take customer happiness as a priority. And whenever we build something, we think about the user experience. And it's challenging to ensure that the user experience stays consistent and doesn't degrade as you grow. There are multiple parts to it. One is the user experience on a shared cluster. How do you ensure that it doesn't get affected by some raw customer on the cluster or some planned maintenance on the cluster? Another side of the story is in general user experience when interacting with our services. For example, you have a topic which has data, which is encrypted, and you want to grant access to that topic to multiple teams within the company. The whole workflow of requesting the access or granting the access should be seamless, and that's the beauty of what we do. Another challenge, but it can be challenging to do it once you have a lot of teams and the number of services and the interaction between them increase. Another challenge for us is building a product which just works for everyone. Oftentimes, people have different requirements and ideas of how they want to use a feature or product. And once you have a large number of customers, it gets hard to collect requirements, get feedback, and basically build something which everyone is happy with. One challenge specifically for us is migrating teams who are running on legacy queuing systems or have their own active deployments of Kafka. Some of them are quite huge and real-time. So to migrate them onto our services without any downtime is a big challenge for us. So with all these challenges in mind, I'd like to hand over to Charlie, who will talk about some of our solutions.
So as Piyush just mentioned, we started the project in a situation where there was a few existing use cases. There were existing deployments of Kafka, and we wanted to keep operations low on our side, but on the other hand, we wanted to keep what was making Kafka great, as in connecting all these different services, having connectors for everything. So it was really important for us to keep the Kafka APIs and the way Kafka works as genuine and usual as verbatim Kafka. So to do this, we created a bunch of concepts to fit on top of existing Kafka to enable this multi-tenancy story. So there's three main concepts: namespaces, clients, and topics. So a namespace is our level of isolation. It's what we call a virtual cluster. We try to make it as close as possible for a customer so that it looks like a cluster. A team is the final owner of their namespace. By that, I mean a team has the final word on creating topics on it or granting access to topics on their namespace. And we bin pack multiple namespaces on clusters when namespaces are small. But for big customers, we obviously use dedicated clusters with a single namespace on it. But they still use this same concept to make things easier for us. The second thing is a client. A client is really, to us, the identity of an app. It consists of three things. It's got an ID, or a name if you prefer, and then it's got a pair of public-private key. We'll come back later on how we use this pair of keys. Clients exist globally across the entirety of our environment, so all our clusters. This was really important to us because we wanted anyone to be able to connect to any cluster if, obviously, they were a load to. And the final concept is probably the one you're most familiar with, which is a Kafka topic. A Kafka topic is a topic in our environment is actually a Kafka topic. The main thing is that its name is prefixed by the namespace ID, so that's how we declare ownership. And also, we force customers to define capacity in multiple directions. We're actually defining capacity in throughput and an actual retention. And finally, topics live inside a namespace, as I just mentioned. To make these concepts a little clearer, I'll walk you through a little example. So in our example, we've got two clusters. We usually try to keep clusters roughly the same size, even though it's not always possible. So let's say Mehak has a new project, and she creates a namespace on it. When she creates a namespace, she can define some constraint, the most common constraint being the data center for data locality. So once she has a namespace, she can create topics on it, and then other people come in and they create their own namespace. So obviously, having clusters without clients connecting to them is not really useful, and we run our clusters with full ACLs and no access policy by default. So for that, we create clients. Yodong, for example, comes in and creates a client. Now he has a client and he wants to grant access to things. So to do so, he's going to ask Mayak and Kevin to grant the correct accesses. When he actually asks for accesses, he actually specifies how much data, how much throughput is going to use. This is quite useful because it helps a lot on capacity planning because it pushes some of the capacity planning back to the customer rather than us. Customers have their own dedicated slot and then they have to live with it. They can obviously extend it, but then they have to involve us. So it's important to understand as well that clients are just regular Apache clients with very few modifications on our side. So that means we can leverage everything that makes Kafka such a success. That's, for example, wildcard consumption, consumer groups, etc. The only limitation we have is that a single client instance can only communicate to a single namespace. That's because we really wanted to create this idea of a namespace is like a virtual cluster. And with a Kafka client instance, you can't communicate to multiple clusters because then it's really hard to actually do some things like consuming on multiple topics and committing your offsets, for example. So as I mentioned, we use the verbatim Kafka client. We're currently limited to only the Java client for simplicity. But we did a few things to actually make it more usable for customers, getting the onboarding curve much quicker for people that are not familiar with Kafka, but also on the other side, make it slightly easier for us and improve our operations. So now I'll talk a little bit about these features we've added. The first and quite important feature is what we call the envelope and its extensions. So the envelope and the extensions is roughly what Kafka headers are. We created them before Kafka headers were there, and we'll probably migrate to Kafka headers in the future because it does seem to work out pretty well. So these extensions were great because people actually contributed common extensions for common features. For example, auditing our schema store. We also use it, we dogfood it with end-to-end encryption or tracing, for example. So this has been really useful in developing an ecosystem and making it really easy for people to add tracing and then plug that in the rest of their system. The other feature, and something that anyone running multiple Kafka clusters have run into, is actually service discovery. So service discovery is commonly done with a VIP. So VIPs have a lot of advantages. It sums up your entire bootstrap string to a single address, which is quite nice. So you can replace brokers as much as you want without having much issues and without communicating to the client, which anyone who has a lot of clients know that it's really hard to make a lot of people do something. So this was great, but we wanted some more things from previous experience mainly. One thing we wanted, for example, was the being able to know which version the clients are using, but also which configuration the client are using. So if you ever operated a Kafka cluster for other customers, customer always come to you and say, it doesn't work. And usually the first thing you do is, well, what configuration you're running? So now you've lost 2 email round trips or whatever support thing you're doing to actually just figure out something. Your mean time to recovery is extended, which is a bit sad because that's what you actually want to reduce. So now customers just send it on startup, and as soon as they contact us, we can just pull up their config and be like, well, okay, maybe this buffer is a bit small for the throughput you're trying to put through, or something like that. So these are the main reasons why we wanted that. There was one last one, which was actually knowing which customers were running and how many instances they had. and be able to tell them if they have a consumer flipping, for example, or this kind of thing. And then once we had this basic service, we realized there were more things we could do. As the previous talk just mentioned, getting the configuration right is tricky. There's a lot of ways to shoot yourself in the foot. The defaults are oriented towards throughput, whereas most people actually expect reliability by default. So what we did is actually because we already had the configuration from the customer, we realized we could just expand it with some of the boilerplate configuration. For example, if you run a secured cluster, you have at least 3 properties to actually just say which way it's secured. So we expand this boilerplate configuration and send it back to the consumer. This has helped a lot in our onboarding because now customers are down to only setting 3 properties that are pretty obvious properties because they're the properties they actually use to actually onboard on the thing, which is the namespace they want to connect to, the client ID, and a link to their private key that will be used later. So the last feature we'll talk about on the client is secrets injection. So we ended up, because of our setup, having multiple different secrets. Our end-to-end encryption that Piyush will talk about later had a secret. And we run with SASL, which also has a secret. So now customers had a bunch of things, they didn't know what was for, and it was a little confusing. Then we realized, well, we have this public-private key thing. So what we've done is actually, on our metadata store, we encrypt all their secrets with their public key, and that's what we send back down to them with their configuration, and they can expand all that and have a single secret for everything. It's sort of one password for Kafka if you want. So this had another advantage we didn't expect at first, is that it makes rotating things much easier because now we can rotate keys on our side without getting the clients involved, and the same thing for the clients. So it makes things easier. So this is about the features we've added to the clients. We'll now talk a little bit about our operational setup. So we've decided to run with a replication factor of 4 and a mean ISR of 2. The replication factor of 4 was mainly because we wanted to have a cluster with a node down and still be able to bounce the cluster. Having a node down on large cluster does happen fairly often, and you don't want to block the rest of your operations because of that. Then the one thing, and for that we've got to thanks Todd for it, because he mentioned it at the summit last year, and this is something that really resonated to us, is to force customers to set retention in bytes. So usually people actually set a retention in time, and a retention in time is great for a customer, but sort of bad for an operator, because for a customer, he takes his retention in time, times it with average throughput, and then that's it. But in practice, things happen. They have peak throughput that is much higher than they expected, and then they said they wanted 1 terabyte, and now they need 100 terabyte. It's just, these numbers are just made up. So forcing them to set a retention in bytes actually made them think a little bit more about peak throughput and these kind of things. So thank you very much, Todd, for that. So then we try to keep good operation practices, and we'll talk about 2 different, a challenge and feature in some sort. So the first thing is we do all operations through standard workflows. So by that we mean that customers don't directly use the admin client. They go through our own APIs, and this has had multiple advantages. The first thing is we can actually validate that customers are doing things and that things are happening correctly. Sometimes that's bugs, and topics don't get created, or like partitions get missed, or something like that. When customers get their topic, they actually expect it to work, which is usually what you want from software. So we actually validate that. We also enforce that there's a check that there's capacity on the cluster. so that customers can't kill the cluster by themselves, and other things like that. Another advantage of that is to actually be able to pose the the provisioning of topics or other operations. This is quite useful when your cluster is actually in a bad state, or if you want to do like a riskier operation than usual, and you'd rather the state of the world to stay a little stabler. So this is quite nice because these workflows will actually buffer all these topics, etc. So it won't return an error to customers. You won't tell to customers like planned downtime, like you won't be able to use our UI for a while. It's just, well, it's going to take a little longer. And then the other thing is something that we actually we thought would need less work is to keep configuration coherent across all clusters. So as your number of clusters grow, actually just adding a single property can become quite expensive. So you obviously don't want to add the property, click bounce on everything, and break everything, right? So you want to do it slowly. Then there's other things. Maybe you want to qualify this new shinier version of Kafka because it's got this great fix that you want. But on the other hand, you don't want to put it on your entire fleet. And you still want to do like push new configuration update on the rest of your fleet. So these are quite a lot of challenges, and it required quite a lot of work, and we're still looking at the right way to do that. So I walked you through a little bit through our client, some of the features we had, and some of the operational choices we made. One of the most interesting things in our setup, we find, is our security setup. So Piyush will walk you through a little bit through it. Whoops.
Thanks, Charlie. As I talked earlier, ours is a multi-tenant environment, and it's important for us to have a security solution which is robust and consistent, but also easy to integrate with, easy to understand and use, and which just like works for everyone. So we are doing some interesting things here. Let's talk about it. It's quite challenging to do security at scale. And like there are some challenges specific to Kafka and to us. So as Charlie talked about earlier, we have this notion of a client, which is globally unique and identifiable. That means any identity of the client is present on all the clusters. And it can be quite challenging when you have a lot of clusters. Another challenge is how do you distribute the multiple secrets to customers in a way which is secure, but also it doesn't make things cumbersome for them. Another challenge is how do you do all the security features while keeping this setup simple on the server side, as well as the client configuration simple. For example, in raw Kafka implementation, if you have to enable SASL or SSL, we have to touch at least 5-6 properties. And as we have seen from experience, the more properties, the more configurations you have, the more easier it is for customers to hurt themselves in the foot. So we wanted to build a security solution which works, but also easy to configure for the clients. Also, the setup is simple on the server side. When you bring up new clusters, we don't have to depend on external service, which becomes bottleneck. So let's see how we do some of the things. For authentication, Kafka comes with a built-in authentication module which supports SASL, SSL. We are using that for authentication. It gives us authentication as well as transport security. In the raw implementation, however, the passwords are stored on the individual brokers on all the clusters. We made an improvement there, and we are storing the ciphered passwords on the Zookeeper instead of the brokers. So whenever client request comes to the brokers, it do the authentication based on the ciphered passwords on Zookeeper. And this is definitely not ideal for us because like you still have multiple copies of passwords on Zookeeper clusters, but still definitely like improvement from what's there in the raw implementation. And we would like to eventually move to a central authentication service which takes care of authentication across the board, but this is something we have not done yet. When we started to think about this problem, we evaluated a bunch of options that are available, like Kerberos, but we ended up not pursuing them because we didn't want to add an external dependency on the servers. For authorization, Kafka comes with a built-in authorizer, which supports multiple operational access for different resources like topics and consumer groups. We are using that for ACLs. What we have done is we have tightly coupled the access control with our quota and capacity provisioning. As Charlie talked earlier, we have this notion of namespace, which has certain capacity. And as you create more topics on it, you use some of the slice available from the capacity. And as you keep granting access or revoking access, it's there where we do all the budgeting and provisioning for quotas and capacity for the clients. We have added a feature here, which is support for wildcard suffix ACLs. We would upstream it soon, and we'll be opening a kip about it in near future. What's this feature? So we wanted a way to configure ACLs without having to specify each line item ACL for all the access identities present. In other words, we wanted a way to add bulk ACLs as long as there is some common prefix that's related to the ACLs. For example, if you have a client which wants read access on all the topics in a namespace, it's not really easy to do that for all the topics that are present in the namespace. So we have a way we can just specify the name of the namespace, followed by the wildcard star ACL, and it just grants a read access on all the topics in the namespace, even to the topics which will be created in future. This can be used in more broader sense. For example, we don't really have control over what consumer group IDs a client may use. And so we come up with a convention that any consumer group ID that a client uses has to be prefixed with the client name. And you can just grant a bulk ACL on the client name on the consumer group. And we don't have to store what consumer groups each client are using. So it really simplifies the access control story for us. One of the main and interesting feature we have is the end-to-end encryption and decryption. What happens is data is encrypted at rest and can only be decrypted at destination. What this means is like the data remains encrypted at rest. This is one of the features that's missing from the raw Kafka implementation. There are a couple of ways to do this. One of them is encrypt the file system itself, but we decided to take this route. We use a central service for key provisioning and management. And we have a feature where any data which was encrypted using the old keys can be decrypted using the new keys. And this is a very important feature, and we'll see how this is important later. So let's talk about a typical Kafka world. You have a bunch of producers, topics, consumers. Producers can write to multiple topics. A topic can have multiple producers. Similarly, on the consume side, a consumer can consume from multiple topics, and multiple consumers may be consuming from a single topic. We wanted a cryptographic solution which is consistent with this picture. What this means is, irrespective of which producer writes to a topic, any consumer who has access to the topic should be able to consume the data. And this is after taking consideration of new accesses, revocations, everything. So let's see how we do this. Let's consider a simple case where you have a producer, a topic, and a consumer. When we provision topics, we associate a pair of public and secret key with the topic. On provisioning clients, we associate a pair of public and secret key with the consumer clients. Note that producer clients don't have any key pairs associated with them. So for producer to produce to any topic, what it does is it generates a random symmetric key, and it encrypts the message using that symmetric key. And it encrypts the random symmetric key using the public key of the topic. So your message becomes public key of the topic encrypts the random symmetric key, and the message is encrypted using the random symmetric key. If you may note, producer only needs the public key of the topic to produce your topic. That means there is no cryptographic restriction for any producer to produce to a topic. How we do that is using the Kafka ACLs. The interesting side of the story happens on the consume side. So for any consumer who have access to a topic, we put the private key or the secret key of the topic encrypted using the public key of the consumer in a central database. So for any consumer who have access to the topic, it can find this entry in the database, and it can use its own secret key to get the secret key of the topic. And secret key of the topic is all what's required to decrypt the data on any topic. So for the consumer, it can get the secret key of the topic using its own secret key, and it can get the symmetric key stored in the message using the private key of the topic, and it can get the message using the symmetric key. So this setup may look complex, and it is, but as I talked earlier, we do our best to ensure the client configuration is as simple as possible. So what we observed was often the client configurations are common if you have a standard security solution. Even for authentication, authorization, end-to-end encryption, decryption, if your setup is standard, configurations are common across the clients. Only thing that differs is the identity of the client, which is the name, and the secrets it uses to interact with your services. And as Charlie talked about earlier, we have Cafe, which is capable of auto-injecting some of the configurations in the client during startup. So we use Cafe to configure or to inject all these configurations in the client, and all the clients have to do is set one key, which is the private key of the client. So one key to rule them all. So this is our security setup, and I hope you found it interesting and useful. And we talked about all the things we have done so far, and we are doing a lot of things which are very excited about. Charlie will talk about some of these things.
So we made quite a lot of progress, but there's still a lot of things we'd like to do. So I'll talk a little bit about a few of them. It won't be in details. It's just like a brain dump in some ways. So Mesos and Kubernetes both made a lot of progress to run stateful clusters on them. We'd be really interested in looking into more depth because that would reduce our operational overload significantly. The next thing is data rebalancing. Anyone who's been running a large enough cluster for quite a while has probably had problems with data rebalancing. It's probably one of the most challenging operational tasks on Kafka. At the beginning, we thought we'd run data rebalancing as a rare process with a complex algorithm that computed close to optimal assignment for the current state, but this had multiple problems. The first problem is that when you actually execute this rebalancing, it lasts for a long time. Currently, even though it's about to change, reassignments are non-interruptible, so that means it's last. Even if you have a problem, you just have to wait until it's finished. So that was a bit of a problem on our side. Then it moves a lot of data, so it's riskier. And finally, we noticed a couple of times that customers were actually noticing a performance impact when rebalancing was running. One thing customers expect above all is constant performance. So when you actually shave off some of their performance, they start complaining to you, and there's a lot of customers. So we're more thinking now about running data rebalancing as a continuous operation. So that means it would be slightly similar to low latency GC, if you're familiar with this concept, is that we decide that we shave off a constant 10% of performance on our cluster. And so we'd be running small rebalance all the time, which would move very little data, but progressively converge into a better state. This is something we really want to experiment with because it would enable us to also have reassignments actually concentrated on very local parts of the cluster, and potentially, even if things go really bad, to not end up in a state of unavailability. So this is something we'd like to invest some time on. The next thing is smart quotas. You've probably noticed that the way we do quotas don't fit really well in the Kafka world, mainly because we set up quotas between a client and a topic. But in the Kafka world, quotas are set between clients and brokers. So it's pretty complex to actually make both things work. And we've seen recently in the mailing list that there's a KIP open about changing that. And we're really excited to see how that goes and maybe spend time on it as well. The next thing is automatic client notifications. By this, we mean more broadly giving the good observability tools to customers. So what happens is because we run multi-tenant clusters, we can't really ask for permissions to customers to actually run operations. We just do it. That's mainly because if you were asking for permission, you'd actually never do it because customers do always do something important, and so you can never do it. So what we end up doing is just go ahead and work with it. So the one problem with that is sometimes operations don't always go the way you want, and clients actually notice things. So we want to provide a right way to make it really low overhead for us to actually notify that clients that something is happening. This would enable us, for example, if the customer team is getting paid, they can get on and be like, oh, actually, it seems to be strongly correlated with this with the fact that the Kafka cluster is doing operation X. We should probably escalate straight to them. The next thing is we're getting into a point in our operational story that we think we're mature enough to remove some of the human attendance to some of the operational tasks. This is especially important to actually be able to scale up our operations. We're starting to find the right KPIs to actually know when something is not happening as we expect, and this is something we're really looking forward to. Then the last two steps will probably remind you of this morning's keynote from Neha, because they're really close to it. Mirroring is incredibly important, for example, for bringing data from remote data centers to the main data centers and other things like that. Running mirrors is not incredibly easy, and especially when you have a lot of them. So this is something we'd like to invest more time on it to make the story easier. There's a balance between having the customers run their own mirrors and having us running fleets of mirrors, which is something we're trying to leverage to balance as well. And the last thing is Kafka data center failover. There's two main things to do a multi-data center setup. One is the one that the previous talk talked about, which is using Mirror Maker. It's like, well, Mirror Maker or replicate, like a replication tool. There's inconvenience to that is some setups actually lose offset continuity, which is a problem now that usage of Kafka are leveraging more and more offset continuity. And the other thing is mainly the latency delay and the fact that it's really hard to know for sure that you're not losing anything and that the time delay can be extensible. The other setup is what is called a stretch cluster. So if you run in a place, you can have multiple data centers that are close to one another, put your replicas on these data centers, and then expect one of these data centers to go down, but then you still have enough replicas in the other data centers. This is typically done with availability zones in AWS, where you put your replicas in different AZs, and then AWS tells you that only one AZ is going to go down. So we think there might be something in the middle, and apparently Neha as well, in Compliant. This is something we'd like to investigate some more. So we explained a little bit what we've been up to, what we're planning in the future. We're really excited to have given this talk, and we hope you really enjoyed it. We won't be taking questions online, but we can take them offline. Thank you.